Hi everyone, and welcome to our webinar this evening, Agile Metrics for Predicting the Future. I'm Adele Lewis, Community Manager here at eSynergy Solutions. For those who are joining us for the first time, just a little bit about us and an introduction on who we are. eSynergy are a consultancy delivering value from the cloud, and we do that with small, high-functional and experienced teams. As a business, we specialize in DevOps transformation, cloud computing, and data engineering. And we work with a number of organizations across the public and private sector, helping them to solve challenging technology problems. We're a big believer in reusing code and working with agile methodologies. And all of this is underpinned by our teams that we've formed through our communities that we've curated over the past 10 years. The community is really at the heart of what we do, and we really see the importance of sharing stories and providing great talks to our community to upskill, which is why I'm delighted today that we're going to be running a session with Mattia Batterson, Development Manager here at Tesco. And I think now more than ever, we should be considering agile metrics for predictions on projects. And he's going to be sharing with us today on how your teams can use their historical data metrics to forecast and answer key questions with confidence. So before we begin, just some housekeeping. If you have any questions for Mattia, please fire them over through the chat box and we'll get to these at the end of the talk. We are recording the session and this will be made available by email and also posted on our own YouTube channel, We Are eSynergy. Now I'm going to hand over to Mattia to begin the talk. Thanks, everyone.
Okay. Can you see my screen at all?
Yes, we can see it if you just go into present mode. Fantastic.
Yeah, so you can see this. Great. All right. We got the tech done. Yay. Cool. I'm just going to start my timer. And we can get started. All right. Good evening. Let's talk about agile metrics for predicting the future. Oops. There are two key lessons that I want to share with you tonight. These are two important lessons that I've learned about using data with teams trying to make predictions, things that I've done in the last few years working with teams trying to do this. And I've learned these two key lessons over the years, that when we're dealing with uncertain events like software projects almost always are, a forecast will almost always beat an estimate. We need to start thinking in a probabilistic way rather than a deterministic way. We can't predict things in a deterministic way anymore. But to do that, we need to become a lot better at communicating our predictions and our forecasts. Forecasting is all about great communication. We need to learn how to communicate the options we have, the risks that are involved in the work we do. And over the course of this presentation, I'm going to show you a lot of real-life examples of conversations that I have on a day-to-day basis where I use data to make predictions and communicate these predictions to answer business questions. My name is Mattia Battiston. I'm originally from a small town in Italy called Verona, which you might know as the city of Romeo and Juliet, the city of love, lovely place. I'm mainly an engineering manager, but I do quite a bit of agile coaching and every now and then still write some code. I'm currently working at Tesco as a software manager. And I'm co-authoring this book called The Team Guide to Metrics for Business Decisions. So if you find that you like what I'm talking about tonight, you can get this book to learn more about it. And you can get it with a 20% discount if you use this link. So later on, I'll send the slides to Adele, and she can send them out to you, or feel free to reach out to me if you want this link. And yeah, if you want to know more, that's the right place.
Matthew, I just wanted to ask the audience, can everyone hear okay? I've just had two people that are saying that they're just struggling to join with the audio. I think it might be that they're going to rejoin with us. I'm just going to wait to see. Oh yes, others can hear. So I think
Okay.
it may just be a couple of people, so hopefully they'll be able to re-log in. I'll try and send them the link. Thank you.
Okay, I can wait a minute if you want. Let me know when you want me to carry on.
I think we're all back in. Great, thank you.
Cool. So hopefully they can hear me now. That's all right, you didn't miss anything too important. If you want to know more, here's the link to a book I'm co-writing. And let's get into it. Here's the thing, most of the teams that we work with at one point or another need to answer business questions like this. How long is this piece of work going to take? How much work can we get done before this deadline? Can we hit this deadline? These are all very common questions that our teams receive on a day-to-day basis. And the answer in Agile teams tends to be something like this. We rely on estimates, pretty commonly story points, but what I'm saying applies to pretty much every type of estimation technique that you might see around, like t-shirt size or ideal days or anything like that. This is data that I took from one of the teams that I worked with, and this team was particularly struggling with predictability. The stakeholders were complaining that this team was not too good at keeping their promises and keeping their commitments. So for a while, we kept track of what we call the lead time of what we were doing. And by lead time, I mean how long does something take from start to end. So for all the stories that we were working on, we kept track of how many points they were estimated with, and the actual lead time of that story. So how long did the story take from start to end? And we found that stories of 1 point were taking from 2 days to 10 days. And stories of 2 points were taking from 2 days to 20 days. Stories of 3 points took from 6 to 18 days. We found that there was very low correlation, almost no correlation between our estimates and how long things were actually taking. And this is a very, very common occurrence in lots of teams. More and more teams over the last few years did the same experiment and found very similar results. Our estimates have very low correlation with how long things actually take. And by the way, if you want to try this experiment yourself with your own team, with your own data, with the book, we are publishing a bunch of spreadsheets that you can use for free. You just plug your data in and then see what comes out. There are 3 key reasons why our estimates are often so wrong. The first one is that in our teams, in our companies, we tend to have too much work in progress. There's a really high amount of work in progress. Very few teams, very few companies limit their work in progress. And therefore, our process ends up looking something like this busy road, where things are so busy that the size of the work stops mattering, stops being important. Because it doesn't matter if something is as small as a bike, a car, a truck. You could even be a Ferrari, but in a road as busy as this, everything moves at the same speed, which is very, very slowly. The second reason is that pretty much in every single process that our teams follow, there are lots of queues. There are lots of states that I represented here in green, where someone is actively doing work on a story, on a piece of work. Someone is actively working on it. But there are a lot of states where no one is actively working on something. The story, the piece of work is just waiting for something to happen. It could be waiting for a developer to become available. It could be waiting for the next release, maybe waiting for information from someone. And it turns out that if we look at the percentage of time that a piece of work spends in a queue rather than in one of these green states, we call this metric flow efficiency. And it's been observed that it's usually as low as 5 to 15%. So what I mean is that usually only 5 to 15% of the time on a piece of work is spent actually working on that piece of work. It's quite shocking, but it's really eye-opening. And what happens when we estimate is that our brain automatically only thinks about the time that I will have to spend working on something. So I'm only estimating the parts of work that will go on in the green states, completely ignoring the majority of time that actually a piece of work is spending in queues. And the third reason is, of course, in our day-to-day jobs, we have many unexpected events happening, bugs, blockers, emergencies, things that happen on a daily basis that contribute to making our work unpredictable. And so what more and more teams are getting to is that the only size of a piece of work that matters is that it's small enough. I coach teams to do story slicing, to break down work in as small as possible stories. As long as the pieces of work are as small as possible, then we can stop worrying about estimating that piece of work. We can stop worrying about estimating stories, putting story points on top of those stories, and we can just rely on data and forecasting techniques that I'm showing you on in this presentation. And just to clarify, stories don't need to be the same size. As long as they are broken down as small as we can, then there will be some natural variation in the size of the story, but that will be automatically taken into account because we use historical data for doing these forecasts. What data do you need to get started? It's actually a lot simpler than you might think. So for everything that I'm about to show you, all you need to capture is the start and end date on a story. So as long as you know when a story started and when it finished, you can calculate pretty much everything that I'm about to show you. And it's enough to have 5 to 11 samples to do also all the things that I'm about to show you, to do a lot of predictions. 5 is enough to put you in the right ballpark. From 7, you already start to have really good accuracy. And with 11, you've got something like 90% accuracy, 90% confidence that your predictions are going to be correct. So it's really, you need a lot less data than you might think. 5 to 11 is enough to get started. Of course, if you have a chance, capture a bit more information about the work you're doing, because later on, this will help you analyze the data and figure out what was happening. But if you want to start somewhere, capture the start and end date of a piece of work, and that's enough to do everything I'm about to show you. I usually suggest starting with some spreadsheets to do this sort of analysis and forecasts, and we've published some free ones here. A gentleman called Troy McGinnis is one of the major experts in this subject, and he published another bunch of free spreadsheets that you can use to practice. I usually recommend start with some spreadsheets to play around and learn what you're looking for. And then you can look at some of these tools that I referenced here. They plug into Jira or whatever tool you're using and do a lot of metrics and analysis for you. So the first metric that I want to talk about is lead time, which some people call cycle time, some people call it lead time. Depending on who you ask to, they might use a different term. I'm using lead time, but as long as you are clear on what you mean by lead time or cycle time, it's fine. What I mean by lead time is the amount of time that a story takes from start to end. That start is usually, what in Kanban we call the starting point, the commitment point. This is a picture of a Kanban board that I took from one of the teams I was working with. On the left here, there will be their backlog with a bunch of stories. And this is the point where a story moves from a backlog into the process of this team. And we call this the commitment point. And that's when the lead time started for us. And it goes up until the end. When does a story start being considered done? For this team, some stories were following a continuous delivery cycle, so they could go all the way to done under their control. So the lead time was from this point all the way to done. Other stories instead followed more of a sprint-based cycle and when released every 2 weeks. So the lead time in that case was only calculated as this part of the process. So that's just an example to say that sometimes, depending on different pieces of work, you might need to calculate a different lead time. But once you have this data, you can calculate this metric called lead time distribution. And we use this to answer a lot of business questions. Here is how it works. It's basically a histogram of our lead time. We are counting how many stories have taken this long in the past. For example, here, this is telling me that 7 stories have taken 1 day, 8 stories have taken 2 days, 3 stories have taken 3 days, and so on. And on the right here, we can do some really interesting calculations to use this data. So I know the probability, but because I know how many stories have taken these many days, I know that 13% of the stories have taken 1 day, and 15% of the stories have taken 2 days, and so on. Now, if you sum these up together cumulatively, you get a level of confidence. And basically, these numbers are telling me that 52% of the stories in this team in the past have taken 4 days or less. And over 80% of the stories in the past have taken 9 days or less. And this is invaluable information that we can use to answer real business questions. And here is an example. This is such a common question that every team will get. How long will this story take? So someone comes to us, they want this piece of work done, and they ask, how long will it take? Here is what I do. Here is how I answer this question. I go back to my data, and I look at this line that I've highlighted here. This is the first line where this number turns green. The green here represents a high level of confidence. It's the first line where I have a level of confidence above 80%. So I use this data to reply, and I say that we are 80% confident that it won't take longer than 9 days. Now, it might just take 4 days, but we know that there's only a 50% chance. So I wouldn't make any promise on that, because if we promised on 4 days, we have a 50% chance of being wrong. Now, it depends on how much risk we want to take on. If we said 4 days and it turned out that we're wrong, what would be the impact for the business? What would be the impact to the people that we're committing to? You see how having this data is changing the conversation from give me an estimate and give me a hard number to discussing the risks involved with the piece of work, discussing the value of a piece of work and the impact of not delivering this in the expected amount of time. I also add that in the worst case scenario, we might need 10 days, but we know that there's only a 10% chance that this might happen. And again, we discussed this. So what would be the impact if we do end up taking 10 days on this piece of work? This helps us have discussions around risk and scenarios about what could and couldn't happen and what the impact is of those scenarios. Another example. This is a real life example. This team was working on a software that was released on a monthly basis. In this case, it was a scheduled release every month. And 4 days before the next release, some of the stakeholders came to the team because they wanted this particular feature done. But they asked us this question. The next scheduled release is in 4 days. Can you fit this feature in? Can this feature be done in 4 days? Because if it will be part of the release, I need to train my staff on how to use this new feature. And so again, we go back to our data to answer that question. And our data here tells me that only in the past, only 52% of the stories were completed in 4 days or less. And that's how we answer that question. We're only 50% confident that we can make it. And now it's up to that stakeholder to decide how much risk appetite they've got. How do they want to take the risk of trying to fit this feature in or not, knowing that there's only a 50% chance that it will make it. And they decided to not do it. They said, never mind, let's wait for the next release, but thanks for the honesty. They didn't want to risk training their staff on a feature that might not have been there. They didn't want to risk the confusion because the cost in this case would have been too high for them. Another really useful metric that I use to answer a lot of business questions is throughput, which some people call delivery rate or even simply story count, because that's exactly what it is. It's the count of how many stories the team is completing in a period of time, that period typically being a sprint. So for example, here I can see that this team completed 11 stories in the first sprint, 5 stories in the second sprint. This is sprint number 6, they completed 9 stories in sprint number 6, and so on. It's simply how many stories are completed in a sprint or a period of time. And with this data, we can calculate a lot of interesting stats, but without getting too bogged down into the maths behind this, let me show you how I use these stats to answer questions. And once again, we got some free spreadsheets that you can try and use with your data if you want to give this a try. So here is a common question that our teams receive. How many stories can we complete in the next sprint? Very common question, you know, could be sprint planning or some ceremony where we are planning some upcoming work. And we want to know how many stories can we fit into this sprint? How much work can we fit into this sprint into the next couple of weeks? We go back to our data and I look at these 2 lines in particular. Here is how I read them. The bottom one here is telling me that in the past, in 80% of the sprints, this team has completed at least 5 stories. And in 50% of the sprints, the team has completed up to 8 stories. So I know with quite high confidence that the team is going to complete somewhere between 5 to 8 stories. And that's how I answer. We are 80% confident that we can complete at least 5 stories. We might get up to 8, but you know, there's only a 50% chance. So we can make a strong commitment to these first 5 stories, but we shouldn't make any promise on the other 3 stories on top of that, because we only have a 50% chance of hitting them. And a great way to visualize these predictions is using this technique called rolling wave forecasting. It works like this. Assuming that you have a backlog in a priority order on the left here, what we do is that next to each story in a priority order, we visualize with some color coding, we visualize our confidence that this particular story will be completed in the next couple of weeks. And so we are over 80% confident that the first 3 stories will be delivered. Probably the next 3 stories will be delivered between 50 and 80% confidence. Possibly 2 more, and unlikely the bottom one, the 9th story. This is an extremely powerful tool that I give to my stakeholders, because at any point in time, they can rearrange the order of the stories in the backlog based on how confident they want to be, how confident they want to feel that a particular story needs to be delivered in the next 2 weeks. So if they really need a story done in the next 2 weeks, they should move it to the top where we have high confidence. And the lower they leave it, the more they know that it's less likely to be delivered to them. Another example using throughput, my product owner, but could be a manager, could be anyone, someone wants us to complete 10 stories in the next sprint. Can we do it? Very typical situation, you know, the team might be under pressure to deliver this amount of work because maybe there's a deadline or something. Can we do it? Can we complete 10 stories in the next sprint? we go back to our data again. And the data tells me that in the past, only in 25% of the sprints, this team has completed 10 stories. So we say that we only have 25% confidence. Are we willing to take such a high risk? And what is the impact of being wrong? If we say yes to these 10 stories, knowing that we have such low confidence that we can complete them, well, what is the impact of being wrong? What if we say yes and then we don't hit them? What will happen to the business? And I just want to stress how in this situation, it would be so common for a team to feel under pressure and to just say, yes, we're going to try our best, we're going to try and complete these 10 stories, and then they end up cutting corners or working overtime just trying to do it. Using data instead, we can really look at what is a realistic scenario and set realistic expectations. Data keeps us true to what we actually can or can't achieve, and helps us fight that pressure that we would otherwise feel. And this leads us to ask even more difficult questions and use techniques like probabilistic forecasting. So far we've seen how to answer how long will a story take and how many stories can we complete in a particular period of time. But then here comes this really hard question: how long will this project take? So we're now talking about something big, a project or a big feature, something that could take months to be completed. And how do we answer this question? This is where a lot of teams really struggle, and this is where teams feel really unpredictable. To answer this question, I use a technique called probabilistic forecasting, which is basically what I was just showing. The trick is to use our historical data to simulate what might happen in the future. And we express the results as the list of possible outcomes associated with the probability that that particular outcome might happen. It uses a statistical technique called Monte Carlo simulation, but despite the fancy name, is pretty much a spreadsheet. I'm going to show you how it works step by step now. And yes, once again, we do have some spreadsheets that you can use if you want to try doing what I'm showing. Here is what you need in input. Starting on the right here, you need in input the past throughput of this team. So what I've entered here as an example is how many stories this particular team has completed in the last 11 sprints. 2 stories in the first sprint, 5 stories in the second sprint, 4 stories in the third sprint, and so on. The past throughput of this team. And then on the left here, we give in input the amount of work that we're trying to forecast, how much work we want to complete. So I will still get the team together, do some, talk about the requirements, do all sorts of design sessions, until we eventually break down the work into some epics and some stories. And in this example, I'm pretending that this team broke down the work for this project into 25 stories. Now, we also need to take into account that as we work on this project, we are going to find some bugs. We are going to find some problems to work on. And based on historical data, here I'm pretending that I'm going to find 1 bug every 10 stories. We also need to take into account that as soon as we start working on this project, you very soon realize that there are some stories that you hadn't thought about. There's some work that you hadn't considered. Or maybe you pick up a piece of work and you realize that it's too big and you decide to split it down. So the original number of stories, the original 25, is going to turn into 30, 35, sometimes even 50 stories by the end of the project. With these 2 things in input, we run our Monte Carlo simulation. So in this example, I'm pretending that the team wants to know how long it's going to take them to complete 20 stories. What we do is, I'm going back a slide for a second, we're going to look at our past throughput and extract a random sample from this past throughput. And in this first simulation, in the first step, I've extracted the number 3. And by that, I mean that I'm simulating that in the first sprint, the team is going to complete 3 stories, therefore leaving a total of 17 stories left. And then we repeat. In the second sprint, I've extracted 5 at random. So I'm simulating that after 2 sprints, the team will have completed 8 stories. Therefore, there will be 12 stories in total remaining. We carry on until after 5 sprints, this team has completed 21 stories, therefore completing the full backlog, the full 20 stories that we wanted to complete. So in this first simulation, it took the team 5 sprints to complete the amount of work. And then the trick of a Monte Carlo simulation is to repeat the simulation a few thousand times. And you will have some simulations where it took 4 sprints, some simulations where it takes 7 sprints. You get all sorts of scenarios, and then we look at the probability of each scenario. And again, we know that in 1% of the simulations, the team only took 2 sprints, 17% of the simulations, it took 3 sprints. If we put this together cumulatively, we know that in 85% of the simulations, the team took 5 sprints or less to complete the amount of work. So we're 85% confident that it's going to take a maximum of 5 sprints to complete this amount of work. And that's how we answer. We have about 50% chance of completing the work in 4 sprints, but we are 85% confident that it won't take longer than 5. So it's going to land somewhere between 4 and 5 sprints. Bear in mind that in the worst case scenario, we might need 6 sprints, but there's only a 15% chance that this might happen. And this is, again, when we talk about the impact. If we do end up taking 6 sprints to complete this amount of work, what is the impact to the business? Is this project still valuable if it took 6 sprints? And the key final part is that we will review our forecast after each sprint. What we do, with an estimate, is quite rare that we go back to re-estimate our work. But with a forecast, with these techniques, it's so easy. At the end of each sprint, you just plug in the new data, you plug in how much work the team has completed in that sprint, and we automatically recalculate the forecast and have an up-to-date forecast after each sprint that we can use to raise alarms as early as possible. We detect very early in the project whether we're going to be later than we initially expected. This is an example of that. I call it continuous forecasting. I'm not going to go into the details, but this is a spreadsheet that I was using with basically a burn-up chart showing when the project was going to land. And you see, as the project goes, the burn-up chart keeps being updated with the most recent forecast, which I give out to my stakeholders to let them know in real time when we're going to hit the end of the project. I'm going to skip this example. So if you like what I talked about and you would like to get started, here is my advice. Keep doing what you're doing, but at the same time, start collecting some data. So keep doing your estimates as you normally do, but start collecting some data, and the next time you need to estimate something, also run a forecast on the side. And then as the project goes, keep updating this forecast with your data, and at the end of the project, see what happened. Compare your original estimate and compare your forecast and see which one came closest to the reality. And this usually leads to some really interesting discussions. In summary, what I've tried to share with you tonight is that when we deal with uncertain events like software projects and working in software development, a forecast will almost always beat an estimate. If we think probabilistically, we have a much better chance of making realistic predictions. But to do that, we need to learn how to communicate these predictions. And that's it for me. Thank you very much.
Great, Mattia, thank you so much. We're now going to go over to some questions. I think we've had quite a few coming in already, which is excellent. So
Great.
I'll kick off if you're ready to go.
Yeah. I'm
Great.
all ready. Hit
So,
me.
first question is, do all stories need to be the same size for these forecasting techniques to work?
Yes, it's a very common question, and the answer is no. That's actually a common myth. If I just let me go back to a previous slide to show you what I mean. As long as the team is making an effort in splitting stories as small as possible, then it doesn't matter that stories are exactly the same size. We don't need to stress about that. Stories will naturally follow a variation in size, and this is showing us exactly what that variation is going to look like. We're going to have a lot of small stories falling on the left side here, and the occasional stories that ends up taking 13 days or even longer. But it's not the size of the story that impacts that, it's rather what I was showing at the beginning of the presentation, the amount of work in progress, the amount of queues, the amount of unexpected events that we have in our system.
Great. And I think we had a question around what is a good period of time to take these measurements to get a good sample of the data?
A good period of time. Rather than the period of time, I would look at the amount of samples that you can get. And the maths behind it tells us that as soon as you have 5 samples, you're already in the right ballpark. And from 7 to 11 samples, you've got quite high accuracy. So you need a period of time, as long as you need to get those 5, 7, up to 11 samples. So if you're talking about lead time, you need to complete, say, 11 stories to have those samples. If you're looking at throughput, you might need to complete 11 sprints. But that's where you can start doing things a lot sooner by just having 5 sprints completed.
I think,
or you can use a smaller period of time if you want to collect those samples sooner and maybe collect them weekly rather than on a sprint basis.
yeah, I think they were also referring to historical data on that point.
Yes, okay. So the thing is, when we use these forecasting techniques, the assumption here is that because we're using historical data, we are assuming that the data we're using is reflecting the future. So we are assuming that the future is going to be similar to the past. To do that, I usually advise not using data that is too old. I usually never use data that is older than 6 months, for example. I would keep it somewhere in case I need it later, but I would just use a rolling window. I usually rely mostly on the last 3 months of a team. The last 3 months is usually what gives me the best predictions. So if I've got data for the past 3 months for that team, that usually gives me really accurate forecasts for what's going to happen in the future.
Great. And we've got another question that's come through. How do you use your split ratios? And the second part is, how do you agree what's a change request?
Okay, I might need them to clarify what they mean by split ratio. Sorry, I'm not sure I understand the question in this case. Is there any chance they can send us a bit more details?
Yeah, I'll get a bit
Or if you
on that one.
Or if you want to get in touch with me, I can also maybe start a discussion with whoever asked that directly.
That's great. The unplanned work.
Mm-hmm.
That was what they were referring to with the split ratio, was the unplanned.
Okay. So going back quickly. So we're referring to this thing, I guess. Yes. As I was saying, this number represents the amount of discovery or split ratio that is naturally going to happen in a project. What happens very commonly is that as soon as you start a piece of work, especially if it's a new project or something new that the team is doing, what we've originally broken down the stories into turns out to not be exactly right, because we usually either discover new work or we realize that a story that we had broken down needs to be broken down further because maybe it was too big and we can split it into smaller pieces. This number 5 here is based on actual historical data from this team. So from the past, we know that in this team we tended to create one new story every 5 stories. So that's where this number is coming from. And in a chart like this, for example, if I look at the end of this project, the red line at the top here is actually the size of the backlog. And you can see how in this project, the team started believing that there were only 10 stories to do. And the more work we were completing, the more we were doing, show and tells and talking to stakeholders, the more new requirements came in, and we started realizing just how much more work there was to do. So you see how the size of the backlog keeps growing because of all these new things that we discover or new requirements that came in.
Great, and I know that we've had quite a few requests for copies of the slides, so I think I'm right in saying that you will be able to share those after. Is that right, Mattia?
Yeah. I can send them to you if that's all right, and then you can distribute
share them out. Absolutely. So we'll be sending that out tomorrow with the recording if anyone wasn't able to catch the full session today. So we'll have that. Next one for questions is, how do you encourage teams to signal work is done already? JIRA discipline is surprisingly difficult to improve, leading to waiting and waste.
Yeah, that's a tricky one, especially if we mention JIRA. I mean, it's a common problem. The problem with most tools is that they tend to have inaccurate data inside them because maybe people forget to update them, or sometimes the tool is not configured in a way that actually reflects reality. So the data inside the tool is actually not realistic data. It's a common problem, so I didn't get a chance to get into it tonight. But what I usually do with teams, well, if I'm lucky enough to work with a team that is co-located, I would almost always coach them to use a physical board as well as a tool like JIRA or Trello, for example, so that I would collect data from the physical board just by noticing when a post-it note moves from start to end. Otherwise, if you trust data in JIRA, you can extract data from your tool. You just need to make sure that, as you say, the team has the discipline to actually keep that data in sync and up to date. I do find that once you start showing the team some of these predictions and some of these techniques, especially with engineering teams, if they realize that this means that they can stop estimating, they can stop spending time in estimation sessions, they tend to get quite bought into the idea and they want to make it work. And that's quite a strong incentive for them to keep your data, your tool up to date. So I find that if you get your engineering team to buy into this, then they will keep their work a lot more up to date. I hope that answers your question.
Thanks. And we have another one. Do you use data for value stream mapping refinements to identify wastes?
Yes, absolutely. Yeah. Value stream mapping is a technique I love. I use it with a lot of teams, especially when I start working with them, or even at portfolio level. So for the audience that might not be familiar with the term, value stream mapping is when basically you draw the process that a particular piece of work follows, and it could be inside a single team, or it could be at portfolio level. Maybe if we're talking about projects, you draw and map out all the steps that happen along this process, and then what you do is you identify the steps that are value adding. So when we're actually working on something, the steps that in lean we consider waste steps when is actually a queue, as I was showing you earlier, steps when nothing is happening on that piece of work. And absolutely, having data, we can be very precise in how long things are spending in each state, and therefore really annotate our value stream mapping with how much time we are spending in waste compared to value adding states. And data across the industry shows that it's usually as low as 5 to 15%. So our value stream mapping quite usually finds that only 5 to 15% of the time is spent in value adding states, in actually working on the piece of work. The rest of the time is wasted. It's time that we could improve on, time that we could become more efficient with.
Excellent. Well, thank you so much, Matthew. I think that's it for the questions. I'd just like to say a really big thank you for coming on and speaking and joining our community today. It's been super insightful, and I think it's opened up a lot of discussion points and a lot of requests for slides. So watch this space. I think for those that have listened in, I hope you were able to take away as much as possible. And obviously, if you do have any further questions, obviously you've got Matthew's details there, but we'll also be following up with the slides and recording tomorrow, so please do watch out for that email. Great, thanks, Mattia. Thanks, everyone.
Thanks so much for having me.
Lovely. Take care.
Thank you. Bye.